let's talk about the hidden world of technology that you use every single day, probably without even thinking about it. We're going to pull back the curtain on the tiny computers inside all our smart devices, and more importantly, the incredible engineers who bring them to life.
So, quick question for you. How many computers do you think you use before you've even had your first coffee? The answer? It's way, way more than you think. Because you see, most of them don't look anything like a laptop or a desktop. Take the alarm that dragged you out of bed this morning. Yep, that's one. It's powered by a tiny, dedicated computer whose entire life's purpose is to tell time and make a noise. But make no mistake, it is a computer. And that fancy coffee maker you're about to use, well, it's got a brain too. A little processor inside that knows exactly how hot to get the water and for precisely how long to brew. It's a surprisingly sophisticated little gadget.
By the time you hop in your car, you're literally surrounded by them. A modern car has dozens, sometimes hundreds of these hidden computers. They manage everything from your engine timing and brakes to the airbags and the music you're playing. They're absolutely everywhere.
All right, so what are these hidden brains actually called? They're known as embedded systems. And honestly, they are the true unsung heroes of our modern world. So what is an embedded system, really? Think of it this way. It's a computer that's built into something else to do one specific job. It's not there for you to check your email or browse the web. Nope. Its whole existence is about control, sensing, and making things happen. Here's the perfect way to think about the difference. Your laptop, that's a general-purpose computer. It's a jack of all trades. But an embedded system, like the one in your microwave, is a total specialist. It's designed from the ground up to be cheap, small, and super efficient at doing its one thing, which is, heating your burrito perfectly. Let's go back to that coffee maker. It's a perfect case study. On the outside, you just see a little pod and a button, but on the inside, it's a whole symphony of parts. We're talking pumps, heaters, sensors, all being conducted by one little embedded circuit board that's running the entire show. And you can see that whole process right here. The second you pull that handle, you kick off this incredibly precise, automated chain of events. That little embedded processor is the director, making sure every single step, from heating the water to the perfect temperature to measuring the exact right amount, happens flawlessly. So, who are the masterminds behind these invisible marvels? All right, let's step into the world of an embedded systems engineer for a day. Their day is this really cool blend of software and hardware. It starts with planning, but the real meat of the job is writing code. We're usually talking languages like C or C++ because they're super fast and let you talk directly to the hardware. Then they have to physically integrate that code with the chips, sensors, and boards. And finally, they test the living daylights out of it to make sure it all works in the real world. But it doesn't always go according to plan. This quote right here just nails the reality of the job. You're working at this crazy intersection of the digital and the physical worlds. And that is where the absolute trickiest problems love to hide. Oh yeah, debugging is a huge part of being an embedded engineer. It's like being a detective, hunting for these microscopic, elusive glitches where the software and the hardware just are not on the same page. A lot of it's done with simulations, but the real work, that often means breaking out amazing tools like oscilloscopes to literally see the electricity flowing and pinpoint exactly where things are going wrong. And that right there, that really gets to the heart of it. This is the fundamental challenge that every single embedded systems engineer is hired to solve. I just love this quote from an engineer on Reddit. It sums up their entire mission perfectly. Their job is to bridge the gap between the real world and the digital world. They write code that takes a signal from a real-world sensor, thinks about it, and then makes something happen in the physical world. It could be spinning a motor, slamming on the brakes, or, just brewing your morning coffee. And what that means is their scope of responsibility is massive. When a smart device glitches out, the buck often stops with the embedded engineer. Is it a software bug, a hardware failure, a network problem? They have to be the master of the entire system, from top to bottom. The pressure is on. Let's look at a really high-stakes example. Here's the problem. A car's network of sensors, radar, laser, cameras, all scream at the same time that you are about to plow into the car in front of you. This is a real-world crisis, and it's happening in fractions of a second. And here's the solution, delivered by an embedded system. In an instant, it processes all that sensor data, makes a literal life-or-death decision, and takes physical control of the car, applying the brakes faster than any human ever could. That is what this is all about. saving lives with code and silicon.
I mean, when you see that kind of life-saving tech in action, it becomes crystal clear just how critical this field is. And as our world gets smarter and more connected, a career in embedded systems is becoming more important and, frankly, more rewarding than ever before.
And that incredible demand, well, it's reflected in the paycheck. The average salary for an embedded engineer in the US is well into six figures. That number just screams how valuable it is to have skills that bridge both the hardware and software worlds. So, if you're thinking this sounds like a cool career path, you're right. But success isn't just about being a tech wizard. You have to be a lifelong learner, constantly updating your skills. It helps to specialize in a booming field like automotive, medical devices, or the Internet of Things. And don't forget the soft skills. You've got to be a great communicator to make all that complex tech work in a team.
From self-driving cars and AI to entire smart cities, the devices all around us are getting so much more intelligent. So the next time you pick up a smart device, take a second to think about that hidden world buzzing away inside of it, and the brilliant engineers who are building our future, one line of code at a time. It really makes you wonder, what incredible problem will they solve next?